Thank you very much. This talk also has a subtitle, which is HTML Hypermedia APIs and Adaptive Web Design. So I'm very happy to be here. And this is me. I work for a company called J-Way in Malmö, Sweden. And I think I have something important to tell you guys and girls. This summer, I wrote a blog post called Combining HTML Hypermedia APIs and Adaptive Web Design. And it got quite a few reads and some nice Twitter mentions as well. For example, by Jan Moore, Mike Adamson, and also a retweet by Roy Fielding, you know, the guy who invented REST. So stay with me here. The roadmap for my talk today is that I will start to present a problem for you, the problem of platform fragmentation. And my proposed solution for that is to using HTML Hypermedia APIs. And then we'll start to look at another problem, which I call capability fragmentation. And my proposed solution for that problem is that we use adaptive web design. And if we take these two solutions and combine them, we see that the web and the API could be the same thing. That will be the last part of the presentation. So let's start with platform fragmentation. How many of you guys and girls are app developers, Android apps? Raise your hand. Not so many. And how many of you are web developers here? A few more. Okay. So today we have a lot of different native mobile app platforms. As you know, we have like iOS, we have Android, we have BlackBerry, we have Windows Phone 7, we have Windows 8, which is kind of a hybrid platform. And I think we have some problems that we need to deal with, right? If we want to support a lot of them. And one problem is that we have a lot of business knowledge in our clients. And what do I mean by that? I mean that, for example, for a particular entity in your system, what are the allowed views for that entity, for a particular state of that entity, and what are the allowed actions on that entity for a particular state of that entity. And that could also be combined with the state of the user and the user role, and perhaps also the state of the system itself. So this knowledge shouldn't really be in the client. It should be somewhere else, perhaps on the server. And some other business knowledge that clients knows about is all the URLs to the API where all the views and actions are. That shouldn't be in the clients either, right? And there are some more examples like metadata for stuff that you send back to the server, type information, validation rules, etc., etc. And I think that this knowledge often comes like in the form of a requirement specification or some kind of other form of documentation, so-called out-of-band data. And one consequence of this is that the business knowledge, the code implementing that, will be duplicated on all the client apps, which is kind of bad, right? So, and the implication of this code duplication is, of course, that we develop very in an ineffective way, and it's both hard to develop and to maintain the app and to change it, and it's also error prone because you have to make all the changes on every platform, right? And then another problem, I don't think that how we do today, if we develop 100% native apps, I don't think that scales if we want to support a lot of different platforms. But on the other hand, if we go to the opposite of the spectrum, we see that 100% code reuse isn't really an option either, because those kind of apps often tend to be like kind of gray, dull, boring. It's not really some oomph in the app. It's just showing something. You want to have a good end user experience, right? So my proposition is that you should have a little bit of both, right? You should focus on what the app is supposed to do the best, like the business case for the app, and start identifying the primary use cases. That if you put money on those, that will really get your return on investment. Like think about the Facebook timeline. That's like the really primary use case of that app. And all the other screens I will call secondary use cases. That's just supporting functions like setting screens and what have you. And for those kinds of screens, we would just like to develop the most simple solution as possible to have as low cost as possible. Okay. And if we go to the web, we see that the problems are actually very similar. We have both the business knowledge here too, right? As in the native apps. And also that we would like to really focus on the primary use cases where we get a lot of return on investment. And the secondary use cases should just work without any effort. That would be the ideal. And why single page applications? I mean these rich JavaScript applications that is based on one page, right? So that's where we stand now. But we see that the number of platforms isn't like steady; it's growing. Right now we have getting apps in TVs. And my TV at home has apps. I think there's going to be a lot of adoption of those kind of TVs. I don't know about the specific numbers, but I think it's going to be a growing market. And the game console you see on the right is called an Oya, which isn't manufactured yet. But it will be a game console based on Android. And I will assume that it will have some support for apps, right? And those kind of apps you develop for an Oya will probably not be the same app you develop for a mobile phone. So we have a kind of different, even more number of apps that you have to do, right? So, and we don't know which platforms are going to exist in the future, like in 2 or 3 years from now, but we can assume that the number will grow, right? So, here's what I think it looks like right now. We have these fat clients in all the platforms, including web, and then we have some unknown future platforms that we know will be fat too. And I believe the reason that we have these fat clients is that we have a very skinny API. Very often we see APIs that just serving some JSON from a data store. And I think that we need to reverse this architecture. And one solution for this, I think, is to start developing an Hypermedia API. So what is the difference between REST and Hypermedia? Is it like if you use only REST, you're a gray, boring guy, and if you use Hypermedia, you get a lot of hipster points? No. But Hypermedia is, I mean, in the beginning, I think REST and Hypermedia was the same thing in Roy Fielding's thesis. It wasn't any different. But I think in many APIs today that call themselves RESTful, there is one big piece missing from these APIs. Something Roy Fielding calls Hypermedia as the engine of application state, HOAS, where you let Hypermedia drive your application. So, and I think it's kind of a good thing to start talking about Hypermedia instead of REST, since lot of APIs says they support REST, but missing Hypermedia. So let's focus on the missing part of APIs, I think. So with Hypermedia, you can expose all these things that I talked about, like the business knowledge. What are the allowed views and actions on entities for a particular state of the system? And a lot of metadata and forms and stuff like that. So to be a bit more concrete, I think that we shouldn't expose only like the data store with a thin API. I think we should expose use cases instead. So I have a little story for you. And it goes like this. Like once upon a time, there was a user that came to your application, to the main view of the application. And on that view, the user navigated to another view following some form of link or clicking a button or something. And on that other view was a form. And in that form, the user saw a drop-down that we know pointed to some kind of property on an entity in the API, on the server. And on that, in that drop-down, it told the user what the valid options were for that property in the domain. And the form also contained information about what HTTP method that it would like to be used when sending back the data, and also the URL to post the data back to the server. And that is what I mean by exposing a use case with Hypermedia. If you didn't expose, for example, the options, valid options for the dropdown, the client would need to fetch that from some other place, like some other URL for a data store, to create that, some kind of relationship. But I think it's much better to send all the information needed to display a certain view. So if we use Hypermedia instead of skinny APIs, I think that the landscape will look a bit more like this. That we have thin clients instead, and of course a more fat API. And the cost, I think the cost of building this API will of course be a bit more than a skinny one. But on the other hand, the cost of building all the clients will be less. So that means that we can make an investment in the API and start scaling out, building a lot of different app platforms. So, and when you start thinking about designing your Hypermedia API, you you need to think a lot about what kind of media type should you use for that API. And Mike Adamson here to the right has a nice compilation on a website of his, where he lists a lot of media types and has something he called hypermedia factors, which I won't have time to explain today, but I recommend you to go to that site if you're interested. And this is a hypermedia factor pyramid, and I will talk about a few of those. But so it's important to choose something that matches your system, your requirements the best. And if you find that no media type does that in a good way, then perhaps you could build your own, but that would take a lot of time and effort. So if you could reuse some media type, that would be the best, right? So an example of an hypermedia factor is support for outbound navigational links. And in HTML, that's just an href. It's nothing special. So it's almost too simple to show you. But this is, I mean, it's extremely important factor to have in a Hypermedia system, because without links you can't navigate in the API. And another example is support for non-idempotent updates, which in HTML would just be a form with a post. So if we look at the hypermedia factors for HTML, we see that the pyramid is almost full. HTML is one of the best media types if you want to support as many hypermedia factors as possible. And I will talk about one of these missing boxes in a while. And but that's not the only thing that's good with HTML. There's a lot of other advantages using it as well. And if you want more details on these advantages, I'd like you to go to Jan Moore's blog post, using HTML as the media type for your API, where he goes into a lot of details. But some of these are that HTML supports very rich semantics and data types. So for example, you could use a set in HTML, and that's an unordered list, right? So you can kind of play with that. And it also supports regular lists, an order list, the OL tag. And also it supports a kind of map dictionary with the definition list. But that's not enough. That's just semantic stuff for like data structures and stuff like that. So what about our domain? How could we model our domain in HTML? Well, it's kind of a nice thing because you can have a kind of meta layer on top of HTML called microformat style that I will show in a couple of slides. That allows you to describe your domain model in HTML. So hang on, I will show you in a few slides. And that's a very powerful feature, actually. Not something you can easily do with some other data types, or media types. But I think that the nicest thing with HTML is that it's really, really old. It's like almost 20 years old. So I think almost every developer at least knows how to read HTML, understand that, oh, this is HTML. And even more people than developers, people editing articles, what have you, sees that, oh, this is HTML. So it's a very, very well understood media type. And it's also something that's been standardized a lot, so it's very robust. And we know that it works. It has stood the test of time, which is not something you can say about a lot of other media types right now. And another good thing is that there's a lot of tooling support for HTML. For example, on the server side, you have all these HTML templating engines, MVC frameworks, that MVC frameworks use, like templates. And also good syntax highlighting, code completion, also editors that know which tags can go in other tags and attributes and what have you. So they know HTML, which is something that if you go for other media types, it's perhaps not always like that. And on the client side, we have, for example, libraries for parsing HTML and traversing HTML, which I will show you a bit later. But the most important thing on the clients is that we have a way to render HTML, which is called a browser. And a browser exists in every platform. So, which, if you compare with other media types, is just data. You have to find a way to render it yourself. But in every platform, there's a browser. So that's a very cool thing, that you can always show just directly to the user what's being sent from the server. But to be fair, there's also some objections against using HTML as the media type for API. And I will talk about two of them. For the first objection is that HTML only supports get and post. So how could it be support REST. Like you should have put and patch and delete in your API if you want to follow REST principles, right? So it couldn't work. But if you listen to Roy Fielding, in 2009 he wrote a blog post where he describes that get and post is the minimal requirement for having a RESTful API. That's because you want to separate on operations that have side effects and those operations that has not, which are safe. So, and if Roy Fielding says it's okay, it's enough using get and post to be a RESTful API, then yeah, it's enough because he decides what's REST and what's not REST. So that's not an issue. But perhaps more, a bigger issue perhaps is the how to parse HTML and how to traverse it. So that's two parts. But for parsing, I mean, how many of you has written a JSON parser? Because nobody writes parsers. We use parsers. So, and there exists a lot of both JSON and HTML parsers out there on many platforms. So parsing is not a problem. We just use the library. So traversing is actually a bigger problem. And so for that, JSON is of course a bit better because you get your JSON data serialized to classes and then you just traverse them with dots. In HTML, the scenario is quite different. But I think it's not a very hard thing to traverse HTML because you have in a lot of platforms CSS3 selector syntax that allows you to traverse it in a style that if you use jQuery, it's very familiar with. jQuery uses the CSS3 selector style. And that's extremely simple to use. You shouldn't XPath. It's hell. CSS3 selector syntax is good, right? So that was some objections. But I think the pros are outweighs much more than the cons in this case. So here's an example of an hybrid app on a native platform. So if we go and identify the primary use cases first, we can develop those with only native technologies, native controls and what have you, and consume the API, the Hypermedia API, as a regular API, except that you get a lot of metadata and you just only have like one request response and then you show the view. So it's more efficient too. And then you use some native way to sending the data back to the server. But for all the other use cases, the secondary use cases, which I believe are the number is many more of secondary use cases than primary. If you think about the Pareto principle, the 80-20 rule. Then you could just render what the server sent with some form of web view, like I believe we saw in Per and Martin's talk today on JavaFX, right? Yep. So that's extremely cheap solution to just, oh, we got some HTML, let's just render it. And then you're done, right? And if you have a form, you can use that the form on the web page to send the data back. And perhaps you have to modify the CSS a bit in order to have the look and feel the same way as the rest of the app. Here's another example. I hope you can see an example of the microformat style. So we see here that we have some kind of messages, an ID with messages. So first I have to say that the microformat style is describing the domain with using ID attributes and class attributes. So we have some kind of messages element here. And inside that we have a unordered list, which happens to be indicated that it has only one element inside of it. And then comes the element with the properties. For example, message text, which contains the text, message text. And then some other stuff. And then we have a link. And the relationship between this page and the stuff that the links points to is called a message. So we have some kind of semantic here, semantic relationship. Then we have the URL, and then the title, message, the title of the link. And then the actual, what will be linked, the content, which also has a property, a datetime. And that it's that simple, like the microformat style. You just describe your domain using class and IDs, attributes. And here's an example of the CSS3 syntax with using jQuery. So you go to the messages, the ID messages element, and then you traverse and taking out the message text property from here. So you get a list of message text, but in this case only one. And I won't have time to tell you more about Hypermedia APIs and HTML today, but I recommend you to read the book by Mike Emerson, Building Hypermedia APIs with HTML5 and Node, which has a very good chapter on designing Hypermedia APIs, and also a very good chapter about having HTML as the media type of API. And then he has 2 more chapters about some writing JSON APIs and XML APIs. That's pretty good too. But I would focus on the HTML part and the design part, right? Also, there's a kind of ebook, blog, wiki thing that by Steve Kladnick called Designing Hypermedia APIs, which is also very well recommended. So, that was about everything about platform fragmentation and the solution to that HTML Hypermedia APIs. So, now I want you to kind of forget everything I said, just reset your brains, and then we can start over with another problem, which is related, but a bit different. And then I will tie it up in the end. So, capability fragmentation. What do I mean by this? I'll try to give you an example. For example, laptops. On the right here, we see a MacBook Pro, which is a kind of good computer, high quality computer, but also kind of expensive. And on the on the left side, of course. On the right side, you have a kind of netbook, which for many people is a good enough computer. You know, just emailing, checking Facebook, reading news. And it's very, very cheap right now. It's in American dollars, I think you can get one for like $350 or something, in Sweden at least. And then you have all the stuff in the middle, like not netbooks and not MacBook Pro, but something in between. And that's what I mean by the fragmentation of this particular market. And if you start thinking about the mobile markets, it's exactly the same thing. You have good like iPhones and Nexus and what have you, really good quality phones, but they are quite expensive. And then you have really cheap, good enough quality phones for regular users, and they are very price worthy. Some people think. And then you have all the stuff in the middle there too. So, fragmented market. So, predicting the future, I think that a lot of people will actually, if you think about end users, I think that a lot of people will go for cheaper devices, like good enough quality. And so the majority of users will be in the low-end part of the market, low to middle end. And we will have some users that will be power users and have really high quality stuff, for example, as developers. But if we want to support the end user's machine, we have to start to think to support devices with good enough quality and maybe not the best performance, right? So in 2011, a company called NetBiscuits collected some data from their websites. In total, 8.5 million unique visits. And here's what they found. They found that 40% of these visits, and it was only the mobile section of mobile devices they measured. 40% of these visits came from 3 different types of iOS devices. And the rest, 60%, came from 3,112 other types of devices. And none of these 3,112 other devices had more than 3% of that unique visit count. And that's a pretty long tail, right? But to be honest, of course, a lot of these devices in the long tail are Android-based devices. But I think we can assume that if you look at all devices in this picture, they will differ a lot in screen size, in performance-wise, and also what kind of features they support. So, and this makes a really fragmented picture of the mobile space, right? So, is this a problem for native app developers? I think that it's perhaps a problem with screen size currently. That we have to adjust our applications to suit some different screen sizes. But I think in the future we will see that performance will be a bigger issue, and also perhaps supporting different kind of features for the same phone, but on different versions of an operating system, for example, Android. But for web developers, the problem is much worse. It's huge. If you think of the web as one platform. So we need to remember that this is not the web. It was the web like 10 years ago, but this is not the web, not even with laptop. This is the web. With tablets, laptops, cell phones, smartphones, e-readers, TVs. And this is only a simplified view. Remember the 3,000 and so on devices that I show you. It's really huge. And so this is now. What about the future? This will be the web. We will probably see web browsers in very strange devices. For example, cars, refrigerators, printers, watch, I don't know. It could be anything. But maybe most important, it will be a lot of strange devices that we couldn't even imagine right now being developed maybe just a few years from now. We don't know what they will be. But I think we can assume that the probability is high that they will have some kind of web browser inside of them. And so we need to have, I think this demonstrates that we have to have a good cross-browser strategy for our web app. And so now we'll talk about adaptive web design, which is a solution to this capability fragmentation problem. And adaptive web design, if you read the book by Aaron Gustafsson, is essentially, he says that it's essentially the same thing as progressive enhancement. So I will interchange these concepts for the rest of the presentation, just for your information. And so progressive enhancement, it's a kind of a bottom-up strategy. So you start with supporting as many browsers as possible, go for simple solutions, and then if a browser comes to your site, which is like a very modern, like a Safari on a Mac or Firefox, modern browsers, yeah, you know, all the regular laptop browsers. You can enhance the page to make those users get a much richer experience than, for example, on a mobile phone. And a good metaphor for progressive enhancement is an escalator. Because an escalator can never break. It can only become stairs. So it's very fault tolerant. If the engine breaks, you just start to walk, right? And so another cross-browser strategy is graceful degradation, which is a more top-down strategy, where you start implementing for these modern browsers. And if a browser comes to a page that has less capabilities, doesn't have many features, then you try to at least do something to show the information or service or exposing some feature in another way. And I think perhaps a good metaphor for that would be an elevator. And so, and if an elevator breaks, yeah, you're stuck. And what I mean by this is that graceful degradation often, it doesn't come all the way down. Often, it's not what I recommend. So I think that if we value mobile, and mobile is growing and growing, that market. If we value mobile, we should not go for graceful degradation. We should go for progressive enhancement and starting developing for mobile. So, as I just mentioned, that is a good way to start. Mobile first. I just want to tell you, this is something. I will have a few things to say about progressive enhancement, but I won't have a lot of time. I think that you can have several talks about progressive enhancement if you want, but I will just mention a few stuff that I think is important. So as I said, you should go mobile first, and if you go mobile first, you will have to start thinking very carefully about the content that you want to show to the user, because you have a very fixed, very limited screen size, and also a very limited bandwidth. So you have to prioritize quite hard, right? And if you are exposing some kind of service from your server, like Twitter, you have to start thinking about how the use cases will look like, and start thinking about how they will behave on a mobile. And that makes sense if you believe that mobile is very important, if you start with that. And that ties in quite nice with those primary use cases I talked about earlier. Like here too, you have to think about what makes your app unique. What is the business case for your app? So I think mobile first forces you to start thinking in good ways. So another thing that I'd like to mention is that you can use delayed and conditionally loaded content for your web app. And by that I mean that if a desktop browser comes in to your web, you can imagine that there will be a lot of empty space on that screen. And then you can detect that the laptop browser came in, and you can start loading more content with Ajax and start populating the empty space. So that's all I have to say about that. But that's an option for you. And also, a complementary solution is to use responsive web design, to have a different design for different screen widths, and perhaps, I think, how many of you are familiar with responsive design? A few. Okay. So I won't have time to go through this at all. But in short, you can detect how large the screen is, and you can have different CSS rules for different screen sizes. Right. 10 minutes. So last one, important thing. Capability is not connection speed. Just because you have a desktop browser doesn't mean that you can show them like 2 meg site, right? because your user could be sitting on a train, and as you all know, mobile connections on trains, they are kind of crappy. They go up and down, and they are very slow. So think about that. On the other hand, your user could be sitting in a sofa at their home with a 10 megabit Wi-Fi, and then it's no problem to serve lots and lots of data if you want to. So you should decouple the capability of the browser with the connection speed mentally. So if you want to read more about adaptive web design, I recommend you to read this book by Aaron Gustafsson, and also to watch the presentation by Nicholas Sakas called Progressive Enhancement 2.0, and to read the resource-oriented client architecture, rockastyle.org, which has a lot of good recommendations and requirements. So that was about capability fragmentation, the problem, and the solution, adaptive web design and progressive enhancement. So now I'll wrap up my talk with explaining what I mean by this last line, that the API and the web can be the same thing. But it's not very complicated. It's just the API and the web can be the same thing. So an example, if you start doing HTML Hypermedia APIs and try to describe your domain with microformat style, you will see that, as I showed you before, something will be sent from the server in this particular form. And on the other hand, if you start doing your mobile-first progressive enhancement web apps, you will see that if you use a semantic HTML and do good design, you will end up with HTML looking kind of like this. So, like, it's the same thing. So why not put them in the same endpoint, the same solution, and then having a progressive enhancement style and doing more stuff, JavaScript rich stuff for web clients, and having API clients, native clients consume your API. So you have two views on the same endpoint. So of course there will be some compromises that you will have to make if you go this route. But I think that for many solutions, the costs will be much less than the benefits of having one solution, one web and the API in the same endpoint. But it's kind of scary also. So you would like to have some kind of option for the future, so which will let you to split up the solution into a web part and an API part if you want to, so that you have the flexibility to do whatever you want. You don't want to be locked into an architecture, right? So I think the simplest solution to that is to have separate URLs for your web and for your API. So you have like a web URL, www for the web, and then API dot something for your API. And the technical implementation of this could be that you have duplicated DNS entries pointing to the same IP address. And then it's just a matter of updating the DNS, and then you have a split. So that's a simple solution. But I also like to say that maybe you don't have to have a full split if you see a need for this. Maybe you can just split like a 1 or 2 use cases and still keeping the solution very tight, right? Because you can still get a lot of benefit from having the other use cases served as the same thing. So, a pretty cool thing that you could do if you used web and API as the same thing is that you can have this progressive enhancement mobile style web applications for mobile browsers. And then if you detect, like if modern browsers come in, you can load a script and execute a script that clears all the content in the body tag And then the script can go back to the same endpoint, which is now considered as the API, and start pulling data from there, acting in the same way that a native client would do. So then you have both mobile first, progressive enhancement style web app, and then on top of that you have a single page application, which is a very rich user experience. So I think that's kind of a cool thing that you can do with this architecture. And I think there's a lot of more benefits to it too. So just a quick recap for the native platforms. I showed this slide before with a hybrid application. With primary use cases, you consume your API, the Hypermedia API, and using native controls for primary use cases, making the end user experience really, really good for those, having good return on investment. Nice stuff. And then for secondary use cases, you used just a web view, and that's like for free, and have a native, have a like form post back to the server. And if we look at the whole picture, what I've told you today, we see that we have these skinny hybrid clients on the native left side right now. And they are skinny because we have a rich API serving Hypermedia and using HTML as the media type, which allows us to use these web views for secondary use cases. And then for web browsers, we have this mobile first, progressive enhancement, adaptive web design implementation, and perhaps also a single page application on top of that for modern browsers. So this is what I see like an interesting architecture. And I think that even if you don't follow this route, this architecture, I think that the need for vision and the need for creativity and the need for good architecture and design in this landscape, and what we see in the future, that the native app platforms is growing and growing, and there's a lot of different browsers, and there will be many, many more. I think that we need to start thinking, right, about architecture, design, and be really creative. And I've shown you what I think is a good solution to this problem. So, just a quick summary of what I talked about today. I talked about the problem of platform fragmentation, and the solution for that, I think, is HTML Hypermedia APIs. Then I talked about another problem, capability fragmentation, and the solution for that is adaptive web design, progressive enhancement, mobile first. And then I show you that the API and the web can be the same thing. But I also like to say that this is not only the structure of my talk. I think that this will be the structure for the future. I think that platform fragmentation will be the driver for HTML Hypermedia APIs, and capability fragmentation will be the driver for adaptive web design. And then the world will see that the API and the web could be the same thing. But now I've shown you to you, so why don't start building this solution and start thinking about it, right? You can get a competitive advantage of being one of the first early adopters and make some good money. So I don't think I will have time for questions, but I can speak with you afterwards if you like. So thank you very much. Here's my Twitter account, Twitter name. Thank you.